Page integrated 3, this is problem 1-117, and it says Micah was given $200 for his birthday. Each week he spends $15 on comic books. In how many weeks will his birthday money be gone? Create multiple representations, a table, a graph, and an equation for the relationship between the weeks since Micah's birthday and how much money was left. How does each representation show the solution to the problem? So I think the way I started this one is I always want to start with the equation. It's my favorite because I know I got to make all of these things anyway. So I looked at $200. So I know he starts out with $200 and he spends $15 every week. So I know it's going to actually, at first I thought it would be plus 15, but it's not. It's minus 15 because they're taking away $15 out of the 200 every week. So I made it kind of like that, like a line. And then I solved it, I set it equal to 0 so that I could solve it. And so I actually brought the 15 to the other side, and then I divided both sides by 15. And if you put that in your calculator, 200 divided by 15, it's about 13 1/3 weeks. So that means on week 13, I actually went ahead and did a table too. So the first week he just got before he starts, he's got 200, which I kind of did the table and the graph at the same time because I know the starting point is 200. And then I know down here is going to be about 13.3. And I want to see, I don't know, they told me to make a table and a graph. So I went ahead and carried through my table a little bit. I see that we're subtracting $15 every week for each comic book he buys. So I just subtracted 15, subtracted 15, subtracted 15. We still got $155 left after 3 weeks. So then I know that in 13 1/3 weeks, he's going to run out of money. So I wanted to see what happens in the 13th week. So I put a 13 in there and I ended up with, whatever 15 times 13 is. And I subtracted that from 200 and I just got 5. That's just a 5 right there. I got 195, but then I had to subtract it, or I went 200 minus 195. I got 5. So he had $5 left on the 13th week. But then on the 14th week, I plugged 14 in there. And he ended up with negative $10. So my 13 1/3 makes sense. And now I have a table. And now I have an equation. And here's a graph. I think I could fix it up by saying that's 13 and that's 14 if I wanted to. I don't think it has to be a really super great graph. You could probably make a nicer graph than that. And then it asks, how does each representation show the solution to the problem? So on the equation shows the solution by solving for C. I have to set it equal to 0 to solve for C. But on the graph, the solution is shown on the x-axis. It's the x-intercept, isn't it? That's the x-intercept. And then on the table, it's where I get 0. But, I could plug in 13 1/3, and that's exactly where I would get 0. So on the table, it's just showing kind of somewhere in between 13 and 14 weeks. And that's all. I think that's good enough for that one.